So let's look at a couple of examples using distance and displacement and solving for them. Oh, and here we go, a 400-meter race. A student is practicing for a 400-meter race on a 300-meter long, straight east-west track. The student starts on the east and runs the length of the track to the west end, turns around, and runs 105 meters back before stopping. Find the final position, total displacement, and total distance traveled by the student during the run. Okay, I'm going to start by drawing a diagram. Our student goes an initial displacement of 300 meters to the west, 300 meters, because they start on the east side of the track, and they travel to the other end of the track on the west side. Then they turn around and go back 105 meters. So I'm just sketching out those two displacement vectors for my student. Now the other thing we need to do is pick a positive and negative direction. I'm going to label that over here. Let's say to the right is the positive direction, and that's also going to be east. The left is our negative direction, and that's west. So we need to find the final position, total displacement, and total distance traveled by the student during the run. Well, the final position is just where the student ends up. So if we started here and we end up right here, then our final position is going to be represented by this vector, x final. So let's, well, we can just use subtraction to solve for that. The total distance is 300 meters, but we came 105 meters back. So we do 300 meters minus 105 meters equals 195 meters. And I'm going to do a solutions box over on the right side. Solutions. So I would say that x final is equal to, well, it's 195 meters, and it's to the west of the starting point. So 195 meters west of the starting point. West of start. Okay, next up we need to find the total displacement. And actually, we did find the total displacement. But we can do it in a different way. I'm just going to add up all the individual displacements. So S total is equal to S1 plus S2. Now the first displacement is 300 meters, but it's in the negative direction. So that's going to be negative 300 meters. And then we do 105 meters in the positive direction plus 105 meters to find our total displacement of negative 195 meters. Now, since this is a vector, that negative sign just means it's in the west direction. So our total displacement is S equals 195 meters. And we could say negative 195, but since it's to the west, let's say 195 meters west. Last of all is the total distance traveled. And the total distance traveled is the total length of the path. So, well, the student travels 300 meters west, and then 105 meters to the east. So traveled 300 meters at first. It's going to be D1 plus D2. It's just going to be 300 meters plus 105 meters equals 300 plus 105, 405 meters. So our distance is 405 meters. That's that. In this case, our position and displacement are the same, but our distance is different. Let's do one more example. City blocks in Fermiopolis are 200 meters by 200 meter squares. Enrico is on the corner of DRX Street and Feynman Boulevard. He travels 2 blocks east, 3 blocks south, then 1 block west, where he meets his friend James. They summarily discuss statistics. Find the distance Enrico traveled, his east-west displacement, or his x displacement, his north-south displacement, his y displacement, and then the magnitude of his total displacement. So again, I'm going to start this with a diagram. Looks like he travels 2 blocks east. This is his starting point, let's say, start. He travels 2 blocks east, but each block is 200 meters by 200 meters. So 2 blocks is going to be 400 meters. 2 blocks east, then 3 blocks south, 1, 2, 3. 3 blocks is going to be 600 meters. Then 1 block west. That's going to be 200 meters. And that's the motion. We need to find his x displacement, his y displacement, and his overall displacement, and the distance traveled. Well, let's start with the distance, because that's the easiest. Distance, we can do it in red. Distance is equal to d1 plus d2 plus d3, or the sum of the distances. It's just going to be 400 meters plus 600 meters plus 100 meters, which gives us a distance of 400 plus 600 plus 100, 1,100 meters. That tells us how far Enrico walked. Solution. So D is equal to 1,100 meters. Next up, we need to find this is interesting. It says the east-west displacement. So for the east-west displacement, later on we're going to call it the x component of the displacement. That's just going to be how far he moved to the east or to the west. So I'm going to define east as positive, and I'm also going to define south as positive, which means north is negative, and west is negative. So then his x displacement, we only need to look at the x motion. We traveled 400 meters to the east, so that's going to be positive 400 meters for his first displacement. 600 meters was in the north-south direction. It doesn't affect our east-west motion. And then we did 200 meters to the west, so that's a negative displacement of 200 meters, which gives us an x displacement of positive 200 meters, or 200 meters to the east. We can do the same thing for the y displacement. Our east-west motion doesn't affect that, so all we have to do is look at the north-south motion, and there's only one north-south motion, which is 600 meters south, or positive 600 meters. So sy is just positive 600 meters. Sx equals 200 meters to the east. Sy equals 600 meters to the south. The last question is the magnitude of his total displacement. Now, his total displacement is his overall change in position. So I'm actually going to go back to that diagram and draw my total displacement vector. If I started here and ended up right here, then my displacement vector is represented by this arrow right here. That's going to be our overall S total. And it kind of points in a weird direction. It's not east-west and it's not north-south. It's kind of southeast. But we can find the magnitude or the length of that vector just by using geometry. Because we know that the total, let's do it in green. I'm going to erase this start. The total north-south or y displacement is 600 meters. The total east-west displacement is 200 meters. This is a right triangle. We can find the total displacement just using the Pythagorean Theorem. So let's do that. I'm also going to do that in red. Pythagorean Theorem says, well, it's c squared, the hypotenuse squared, equals a squared plus b squared. So when we plug in our numbers, that becomes s total squared equals sx squared plus sy squared. So s total then is equal to the square root of, well, sx is 200 meters squared, I'll do the units afterwards, plus 600 squared. And we're going to have to plug that into a calculator. Calculator time. Let's see, 200 squared plus 600 squared. And then we take the square root of that. We get 630 meters, rounded to two significant digits. So there's our S total, 630 meters. So there's two problems of different difficulties in which you have to find the distance and displacement of some different motions. Bye.